Hi, Josh Rappaport here with another micro math lesson. So, when students have to find the GCF, in my experience, I found a lot of students feel overwhelmed. They start to feel like, oh my goodness, how many numbers do I have to check? When do I start checking? Where do I stop checking? It seems overwhelming. So, in my last video, I explained what the GCF is, the greatest common factor. In this video, I'd like to present a really nice shortcut on how to find the GCF for two numbers, okay? In the next video, I will show how to find the GCF for three or more numbers, but here we're restricting it to two, because often that's exactly what you need to do. Okay, to start out, basically you need to understand one concept, which is what I call the gap. Now, when you're finding the GCF for two numbers, those two numbers have a certain distance that they're apart by on the number line. For example, if you're finding the GCF for 12 and 16, here's 12, here's 16, those two numbers are a certain distance apart on the number line. So I call that distance the gap. So the gap for 12 and 16 is, of course, just 4. They're 4 apart on the number line. And of course, you can get that just by doing 16 minus 12 is 4. You get it through simple subtraction. Okay, now that's an important concept, as you'll see, for helping us restrict how many numbers we need to check for finding the GCF. All right, now an interesting question to ask yourself about finding the GCF has to do with the gap. And the question is basically this. If two numbers are apart by a certain amount by the gap, can a number that's larger than the gap possibly go into both of the numbers under consideration? So for example, if we're looking at 12 and 16, could a number greater than 4, the gap, possibly go into 12 and 16, okay? Now, instead of thinking about that for 12 and 16, let's think about this for even smaller numbers. As a tutor, I've found it's nice to just think about the smallest case possible, the smallest numbers possible. Because generally speaking, if something's true with small numbers, it's true for larger numbers. So let's use the easiest numbers we can think of. So what we're going to do is we're going to think about 6 and 8. So here's a number line with 6 and with 8. And as we all know, 6 and 8 are 2 apart. So the gap for 6 and 8 is just 2. So the question we're considering is, could a number larger than 2 go into 6 and 8? Now I'm sure most of you know the answer to that already, but what we're going to do is we're going to think about it kind of philosophically, thinking of it sort of generally. All right. So of course we know 2 goes in, but let's just think about why it is that 3 can't go in. So let's kind of explore that. So here's 3. 3 is represented by these pink loops. Okay, so 3 times 0 is 0. We start at 0. 3 times 1 is 3. So 3 kind of hops from 0 to 3. Then, of course, 3 times 2 is 6. 3 hops again to 6. Now 3 does go into one of our two numbers. 3 does go into 6. So then the question is, could 3 possibly go into 8? Why can't it? Well, 3, being 3, is going to hop 3 more spaces. So where's it going to go? It's going to go right past 8 to 9. So in other words, because 3 is greater than the gap being 2, 3 can't possibly go into both numbers. Can't go into 6 and 8. Even though it goes into the first, it's going to overshoot that second number, okay? So this leads us to a really nice lesson, which is this. The lesson is that no number larger than the gap can be a common factor. CF just stands for common factor, nor can it be the GCF. Obviously, if something can't be a common factor, there's no way it can be the greatest common factor, right? Greatest common factor is a special subset of all the common factors. So this is a really important lesson, and if we tweak this just a little tiny bit, we get what I call cool fact number 1. Okay, cool fact number 1, what's that? It's this, that the gap is the upper limit for the GCF. So when you're finding the GCF for any two numbers, all you have to do is find out how far apart those numbers are, call that the gap, and you say to yourself, you know what? I'm not going to check any numbers greater than that gap value. So if the numbers, for example, are 65 and 85, the gap would be 20, because 85 minus 65 is 20, and you say to yourself, I'm not going to check any numbers greater than 20. That's as high as I'm going to check when I'm looking for the GCF. All right, so that in itself is kind of nice, right? You have an upper limit now. But the thing is, it gets even better. The gap gives us even more information about how we can limit the group of numbers we need to test. And here's how. Not only does the gap give us cool fact number 1, it gives us cool fact number 2, which is this. For any two counting numbers, okay, the kind of numbers we're thinking about, like 12 and 16, 6 and 8 and so forth, the only possible common factors, the only possible numbers that could go into both, are the factors of the gap. All right, that's a little bit of a mouthful, so let me explain what that means. That means that once you get the gap, you say to yourself, that's an upper limit. The gap's an upper limit. But not only that, the only numbers that can go into your two numbers are the numbers that go into the gap evenly. All right? Let me give you an example. I'll explain what we're doing here. So, here's the example. Suppose you need to find the GCF for 76 and 84. All right? Using cool fact number 1, we can stop testing numbers at 8 because how far apart are 76 and 84? They're 8 apart. The gap is 8. So don't test any numbers beyond 8. But now, looking at cool fact number 2, we say since 8 is the gap, all we have to look at are the factors of 8. Well, what numbers go into 8? 8, 4, and 2. Notice I put them in descending order. Okay? You'll see why in just a minute. But what that means is the only numbers you need to test for 76 and 84 are 8, 4, and 2 to see if any of those go into 76 and 84. And if you test them in that order, the first one you get will be the GCF. So what that means is out of all the numbers there are, you have only 3 numbers that you need to test. And I don't know about you, but I find that pretty cool, that out of all the numbers there are, this system gives you a way to narrow it down so you only have to test a very, very small handful of numbers, okay? And in the next part of this, I'm going to show you exactly what that looks like. So let's just take a little closer look at the problem I had up a moment ago. So that was this. Find the GCF of 76 and 84. So the gap, as I said, was 8, as we saw. And the factors of that gap of 8 are 8, 4, and 2. Notice we put them in descending order. The reason, of course, for that is when you put them in descending order, then the beauty of that is the first one that goes into both of your numbers has to be the GCF, okay? Because that's the largest one that goes in. So after you get your factors, put them in descending order, first one is the GCF. So then we test them in descending order. We try 8. Does 8 go into 76? No, it goes into 72, so it's going to overshoot 76. So forget 8. Does 4 go into 76? Well, yes, it does. 4 goes into 76 19 times. And then does 4 go into 84? Yes, it does. It goes in 21 times. So we know that 4 is our number. So the GCF is 4. And that means, since 4 goes in, we don't have to test 2, because 2 is smaller than 4, so we're done. The GCF is 4, and that's the end of that problem. So let's now do one problem kind of more like together. So here's kind of an interesting problem. Find the GCF for 54 and 78. All right. So first step, based on cool fact number 1, we get the gap. What's the gap for 54 and 78? Well, those numbers are 24 apart. So the gap's going to be 24. Okay, well, 24 is a pretty factor-rich number. So once you get the factors of the gap, you'll see that they are 24, 12, 8, 6, 4, 3, and 2. I didn't mention this, but of course we skip 1 because 1 going into a number doesn't exactly give you anything very exciting or meaningful. Okay, every number. 1 goes into every number. So now that we've got our factors of the gap, we're going to test them. So does 24 go into 54? Well, think about it. 24 goes into 24 and 48, so it overshoots 54, so that's a no. Try our next number, 12. Does 12 go into 54? Well, it also goes into 48, so it also overshoots 54 because it goes into 60, so forget 12. How about 8? Does 8 go into 54? Well, 8 also goes into 48. They're all going into 48. 8 times 6 is 48, and 8 times 7 is 56. We came close, but it didn't work, so 8 doesn't work either. So now we've gone through 12, 24, 12, 8. Let's try 6, see what happens. Does 6 go into 54? Yes, it does. It goes in 9 times. Okay, so 6 goes into 54 9 times. That's a yes. And does 6 go into 78? It does. 6 goes into 78 13 times. So, there we go. Since 6 goes into both numbers, and 6 is the first one that went into both, the GCF for 54 and 78 has to be 6. And that's all there is to it. So thanks to cool fact number 1 and cool fact number 2, we limited the numbers we needed to check to just these, and going down the numbers in order from greatest to least, we only had to test actually how many? 1, 2, 3, only had to test 4 numbers, and then we found our GCF. Okay, after this I'm going to put up 3 problems for you guys to do on your own to test your hand at using these cool facts and use this little shortcut. And please don't forget to subscribe to my channel so you can get more of these fun and interesting videos, and leave any comments below. I'd love to hear from you. I always invite people to let me know if there are certain math concepts or skills that they'd like me to do a video on, and I'd be happy to consider those. So look forward to your comments and see you in the next video. Thanks so much.